Today's coverage will continue through separation of the rocket's payload fairing. For additional real-time mission coverage, follow along with our live blog at ulalaunch.com. And if you enjoy watching our live broadcasts, don't forget to subscribe to our YouTube channel for access to the future missions, launch, highlights, behind-the-scenes rocket content, and more. At this time, the team is not working any issues, and we're proceeding towards an 8:56 p.m. liftoff. Today's mission, USSF 106, is a multi-manifested flight that will be delivered directly to geosynchronous orbit. Navigation Technology Satellite 3, or NTS-3, designed, developed, and integrated by L3Harris with AFRL, is an on-orbit experiment to help modernize America's positioning, navigation, and timing capabilities by augmenting GPS to make it operate at faster speeds and lower cost. Let's learn more.
The current global position system has provided position, navigation, and timing (PNT) technology to our warfighters. And with the space domain becoming increasingly contested, the United States Air Force and Space Force continue to bolster GPS architecture resiliency. The Navigation Technology Satellite 3, or NTS-3, is a geosynchronous orbiting testbed that will enable experimentation of new PNT technologies and concepts. NTS-3's Agile Waveform Platform is a digital signal generator that can be reprogrammed on orbit, allowing for updates, modifications, or switching of the PNT signals. The NTS-3's large phased array L-band antenna allows it to generate multiple spot beams while retaining legacy Earth coverage broadcast capability. To support the NTS-3 spacecraft, AFRL is also developing software-defined, reprogrammable receivers and a next-gen ground control segment capable of delivering a comprehensive system solution for resilient future GPS services. Aside from generating performance data of our experimental components, this experiment focuses on testing out brand new, forward-looking CONOPS for military PNT. NTS-3 and AFRL Vanguard program will provide robust, reliable, and resilient position, navigation, and timing technology to the United States warfighter.
As we look at the Vulcan rocket on the pad, we see the American flag across the inner stage and logos for the United States Space Force, ULA, as well as mission artwork on Vulcan's payload fairing. This artwork features a Vulcan god in the center, along with a logo for the NTS-3 mission in the top right corner. The NTS-3 logo includes mission-specific symbolism with arrows, a bullseye, the Roman numeral number 3 on the face of an analog clock, as well as a Zia symbol in tribute to Kirtland Air Force Base in Albuquerque, New Mexico, where NTS-3 began and is led by the Air Force Research Laboratory Space Vehicles Directorate. As we continue counting down towards T0, let's learn more about how ULA builds the Vulcan rocket.
Engineered in Centennial, Colorado, ULA's Vulcan rocket is built in Decatur, Alabama, and launched from Cape Canaveral, Florida. Once the rocket is manufactured, it travels to Cape Canaveral on ULA's cargo ship, known as Rocket Ship. After arriving in Florida, ULA's launch operations team begins assembling the rocket. Stacking begins with lifting the 109-foot Vulcan booster, powered by twin BE-4 engines, onto the Vulcan launch platform. For additional thrust at liftoff, solid rocket boosters are attached to the sides of the first stage. Following interstage mate, ULA's ultra-thin stainless steel Centaur upper stage, powered by two RL-10C engines, is then lifted into position. Lastly, the payload fairing, containing the spacecraft, is lifted and mated to the Vulcan rocket. Once assembled, the countdown begins with moving the rocket from the vertical integration facility to the launch pad. The trip to the pad is about 1/3 of a mile. Throughout the 20-minute trip, a support van leads the move, followed by the payload van, providing communication with the spacecraft, and the ground van, providing support to the rocket. The Vulcan launch platform supplies air conditioning, electrical, and propellant lines to the rocket. Track mobiles at the rear power the convoy, which includes an environmental control system providing air conditioning to the payload and rocket, as well as a backup generator. Vulcan arrives at the pad for fueling and other final preparations, and once fueled, weighs nearly 1.7 million pounds and stands 202 feet tall.
As we approach liftoff, I'm joined by ULA President and CEO, Tory Bruno. Welcome, Tory.
Thanks, Chris.
Good to see you.
It's good to see you too.
We're a few minutes from liftoff. How you feeling?
Well, I'm feeling great. I mean, this is such an important moment for us to see Vulcan enter service, especially in a national security mission. The rocket's looking beautiful. The weather is clean. We're pretty excited.
Great. Liftoff's always an exciting thing to see, but equally exciting for me is the flight of the second stage. Centaur is just an amazing vehicle.
Absolutely, especially Centaur 5, and it really makes this mission that much more significant for us because this is literally the mission that drove the design of Vulcan. It's that direct inject to GSO exotic orbit with a really complex payload and an extraordinarily long mission timeline. It's literally the anchor that designed this entire rocket architecture. So as we enter into service, that's really something special. I might have preferred to have done a nice easy mission, but hey, this is what we built this rocket for, and it's about to go do it.
Great. Well, thank you, Tory, for your time. We appreciate the interview.
You bet. Thank you. I'm going to get back on console.
Great.
L-minus 12 minutes. All communications switch to channel 1. All personnel and visitors remain in the present position until launch. Maintain operational silence in the LCC.
Terminal count briefing. If a condition exceeds a launch constraint anytime after the terminal count status check, the observer shall announce hold on channel 1, identify their station, and briefly state the reason for the hold. RLM verify red line monitor and vent tape are in the correct configuration for terminal count. Verified.
LC LOX 2.
Go LOX 2.
Centaur LO2 at flight level.
Roger.
LC Fuel 2.
Go Fuel 2.
Centaur LH2 at flight level.
Roger.
L-minus 11 minutes.
LC switch to ready position. All steps are complete prior to the status check.
We remain in the planned 7-minute hold as we continue towards liftoff. In a few moments, ULA launch conductor Scott Barney will pull the team for the final go for the countdown. The launch conductor coordinates the launch team during countdown, similar to a symphony conductor coordinating an orchestra. 30 engineers are pulled to confirm the rocket is ready to proceed. This is the final status check for all Vulcan vehicle systems, ground systems, the payload, the U.S. Space Force Eastern Range. Let's listen into Scott as he performs the poll.
L-minus 10 minutes.
Status check to proceed with terminal count. Vulcan systems propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LNG.
Go.
LO2.
Go.
Water.
Go.
Centaur systems propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
House gas.
Go.
Electrical systems airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
GCQ.
Go.
Op support.
Go.
Com.
Go.
Umbilicals.
Go.
Environmental control systems.
Go.
Red line monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range and weather.
Go.
Launch director.
Clear to proceed.
Mission director.
This is the mission director. You have permission to launch.
Proceeding with the count. ALC verify T0 is set for 0056 Zulu.
Verified.
ABE, issue
Polling is
MR.
complete and the team is go for launch. From now until liftoff, you'll hear launch conductor Scott Barney and the team performing the final steps in the countdown procedure. Several critical activities occur in the final minutes before launch, including verifying fuel tank levels and pressures in the booster and Centaur, and arming the flight termination system. At T-minus 1 minute, the Range Operations Commander confirms the range is green, in a green condition, for launch, assuring there is no nearby constraints like boats, planes, or weather, and that all tracking systems are operational. At T-minus 25 seconds, you'll hear Go Vulcan, Go Centaur, Go USSF 106. This is the final status check of the rocket and payload readiness. At T-minus 6 seconds, initiation of the launch pad water deluge system occurs. At T-minus 3 seconds, the main engines ignite. Then, after seeing Vulcan lift off, you'll hear flight commentator Daniel Brunson providing updates as the rocket ascends into space. In our launch count, we include planned holds. This means that as the launch team and the launch clock are getting closer to liftoff, the clock will pause for short periods of time to allow the team to resolve any issues that might occur in the hours leading to launch. If you're familiar with launch counts, then you might already know that the L- time refers to the actual time remaining until launch, and the T- time refers to the time that reflects these holds. By building in these holds, we give ourselves a higher probability of an on-time liftoff. As we are currently in our 7 minutes hold, we will anticipate releasing the hold in just a few moments.
Time will be T-minus 7 minutes and counting. 3, 2, 1, mark.
The countdown clock has resumed, and we are go for launch at 8:56 p.m. Eastern Time. After decades of launching our country's most vital assets into space on Atlas and Delta rockets, ULA is proud to continue supporting our nation, launching new capabilities atop our new Vulcan rocket. Let's take a look at our legacy of national security launches.
ULA is proud to serve our country and honored to have launched 100 national security missions. The importance of reliably delivering these missions to orbit is never lost on us. They keep our people safe by keeping an eye on our adversaries, delivering critical information to decision makers, providing communication capabilities across battlefields, on land, at sea, in air, and in space. Helping warfighters find their way on the front line and the home front. Monitoring for missile threats. And testing and implementing new technologies that protect our country and our people. 100 national security launches. 100 missions we proudly enabled. We look forward to the next era of national security missions, launching atop ULA's high-performance Vulcan rocket.
As we approach the terminal count poll, let's check in on today's forecast provided by the team over at the Space Launch Delta 45 Weather Squadron. The probability of violating launch constraints is 20%. Ground winds are 10 knots out of the east-southeast, and the temperature is 84 degrees Fahrenheit. The primary concern for launch today is the cumulus cloud rule. The range is green and for weather, and we are go for launch. Following liftoff, ULA's Vulcan rocket will be flying an easterly heading from Space Launch Complex 41. Here's a look at today's flight.
Following final confirmation of rocket readiness, twin BE-4 engines and 4 GEM 63XL solid rocket boosters produced nearly 3 million pounds of thrust to lift ULA's Vulcan rocket away from Cape Canaveral's Space Launch Complex 41. Shortly after liftoff, the rocket begins a pitchover to attain the proper flight path while minimizing the dynamic pressure it experiences during flight. Vulcan then reaches Mach 1, the speed of sound. With the ability to add 2, 4, or 6 solid rocket boosters, or SRBs, Vulcan can be precisely configured to take any mission to space, from low Earth orbit to Pluto and beyond. These boosters augment the rocket's total thrust at liftoff, adding approximately 460,000 pounds of thrust per SRB. With their propellant expired approximately 90 seconds into ascent, the SRBs burn out, followed by jettison. Jettison time is variable, occurring between 100 and 150 seconds after liftoff, depending on mission requirements. Vulcan's guidance system then activates to steer towards the precise target in space. First stage flight continues as the rocket crosses the Kármán line, entering space. With the majority of propellant expended as Vulcan fights against the force of gravity, the BE-4 engines shut down, and the booster stage separates. With the rocket now weighing less than 10% of what it did at liftoff, dual RL-10C engines on ULA's Centaur upper stage ignite. Spacecraft are encapsulated inside a 5.4-meter diameter payload fairing, which provides a protective environment during ascent. Following Centaur engine ignition, the payload fairing is jettisoned, and the mission continues to its final destination.
Once we lift off, viewers watching the launch from Florida and points east may be able to see Vulcan in flight. To get a closer look at this visibility map, check out @ULA Launch on social media.
Roger.
$159,
Vehicle internal.
$155,
Launch sequencer start.
$140,
Launch enable.
$135,
FTS armed.
T-minus 90 seconds. The launch vehicle, ground systems, payload, and eastern range are go for launch. For those of you just tuning in, I'm Chris Veltri, joining you for today's live coverage of USSF 106 atop ULA's Vulcan rocket. At this time, the team is not working any issues, and we're proceeding towards liftoff at 8:56 p.m. Eastern Time. T-minus 1 minute.
Report range status.
Range green.
$45,
Vulcan tanks at step 3.
$34, 30, DE4 start box go. 28,
Verify ECS routes for launch.
verify. 20,
Status check.
Go Vulcan. Go Centaur.
Go SF 106.
15, 10,
T-minus 10, 9, 8, 7, 6, 5, 4, 3. We have ignition. 1. And liftoff of United Launch Alliance Vulcan rocket carrying USSF 106 for the United States Space Force, continuing ULA's soaring legacy in national security space launch with the innovative Vulcan rocket.
Thrust, half mile in altitude. Completed our pitch and yaw program. Body rates turned to 0. P's down to closed loop control. And we've completed our roll program. 3 miles in altitude, half mile downrange. And Mach 1, Vulcan supersonic. Vehicle's traveling at 1,500 miles per hour, right down the center of the range track. Max Q, maximum dynamic pressure. Engine parameters continue to look good. Hydraulics good. 5 miles downrange.
You are hearing Daniel Brunson providing launch vehicle ascent data.
Good indication of SRB burnout, preparing for SRB jettison. B4s continue to burn nominally. Good indication of SRB separation. B4 is entering its first throttle bucket. And guidance enabled. We've been able to close loop steering. At this point in
We
flight,
just heard
Vulcan's now half
confirmation of solid rocket booster jettison. These 4 motors augmented the thrust of the main vehicle engines at liftoff, giving the Vulcan rocket an extra boost on its journey to geosynchronous orbit.
27 miles downrange, continues right down the center of the range track, traveling at 3,200 miles per hour. Engine continues to burn nominally, body rate's looking good. And we've got activation of the RCS pyro valves on the upper stage. .34 miles in altitude, approaching 4,000 miles per hour. Body rates continue to look as expected. Passing 80 miles downrange, Vulcan continues right down the center of the range track. Passing through 45 miles in altitude, 107 miles downrange. Engine parameters continue to look healthy. We're now a quarter of our original liftoff weight, 169 miles downrange, 56 miles in altitude. Good activation of the upper stage PU motors. Vehicle's traveling 8,400 miles per hour.
This is Vulcan Mission Control at T plus 4 minutes and 30 seconds. We're about 30 seconds away from our next mission events, booster engine cutoff and booster separation, followed by start of the main engine and jettison of payload fairing. Let's return to Daniel Brunson.
And we've completed boost phase chill down.
Drop on, Elsie.
And good indication of shutdown. Good indication of center separation. We've got pre-start on H2 and O2. And good start on the upper stage engines. 2 good at all times. Good indication of PLF jettison. Centaur PU set to open loop control. Body rate's looking good.
This is Vulcan Mission Control at T plus 5 minutes and 45 seconds. We just heard flight commentator Daniel Brunson confirm the successful completion of the early milestones in today's flight, and all systems continue to operate nominally. As the mission continues, let's take a look at the important work done by the Space Force's Space Systems Command.
The ultimate high ground has no ground. The satellites in orbit around our planet provide the critical infrastructure we use to defend and protect the security and prosperity of this world we all share. But space is no longer a benign environment. Adversaries and near-peer nations are actively working to dominate the most critical battleground of our day. At Space Systems Command, the time to act is now. The race is on.
Our adversary is out there. They are going to work every day, trying to work harder, smarter, faster than us. But we are making sure that that does not happen.
The Guardians, airmen, and partners of Space Systems Command are working with unstoppable urgency to innovate and act now, delivering solutions to emerging threats, creating resilient space architectures we can all rely on, especially during times of crisis and conflict.
The fight could happen tonight, it could happen tomorrow, it could happen in a couple of years, but we need to start innovating now, and that's exactly what we're doing.
For Space Systems Command, working faster means breaking from the status quo, exploiting existing space architectures and capabilities in creative new ways, working with commercial industry, innovators and tech startups, and allied nations to exploit, buy, and build, to deliver better, faster, and more affordably.
We are advancing the space architecture that we have up there right now, making sure that it's optimal, making sure that we get new space architecture set up, prototyping, experiments, to ensure that we can outpace the enemy tomorrow.
To maintain our lead in space, Space Systems Command has embraced a new culture, empowering its people to race forward, speak up, and connect with industry in unprecedented new ways.
Our people are agile, they continue our partnerships, they are working collaboratively day after day in order to contribute to the big warfighter purpose.
Space is a team sport. We have to work together to provide integrated, resilient capability and speed in order to fight through any contingency crisis.
Space Systems Command is moving fast to maintain U.S. superiority in space, running a marathon of sprints, thinking differently, acting boldly, empowering at every level to make space work for us all. At Space Systems Command, space starts here.
As we wrap up today's live coverage, I'd like to say thank you for tuning in to today's flight. What a beautiful evening we had in Florida for launch today. We got to hear from ULA's President and CEO, Tory Bruno, about how Centaur is truly one of a kind, and we witnessed boost phase for Vulcan's inaugural national security mission. For more information about ULA, the Vulcan rocket, and USSF 106 updates, please visit ulalaunch.com and subscribe to ULA's YouTube channel. And plan to join us for our next launch, an Atlas V rocket launching Kuiper 3 for Amazon. As we sign off this evening, we'll take another look at today's liftoff. 10, 9, 8, 7, 6, 5, 4, 3. We have ignition. 1. And liftoff of United Launch Alliance Vulcan rocket carrying USSF 106 for the United States Space Force, continuing ULA's soaring legacy in national security space launch with the innovative Vulcan rocket.
Thrust. Half mile in altitude. Completed our pitch and yaw program. Body rates turn.